Okay, how's it going, everybody? So this is our next video. I got some other feedback from students. I'm going to keep trying to make these a little bit better each time. So what I'm going to do here is try and be zooming in and out a little bit more so that the writing is a little bit bigger. So what that means is I'll probably be pausing it more often than I have been in the past, so that I can get the right zoom and get it on the right picture frame, so that hopefully you'll be able to see a little bit better. Okay, so here's where we're going to start today. I'm going to have you guys just do one of these multiplication problems, fraction problems, where we are showing. That means drawing the diagram. And then whenever you do those diagrams, you never have to simplify it, right? So you just literally write your answer with whatever it is that you came up with. And then down here, like I like to do with a lot of new topics, is have you guys do it how you remember doing it. So I don't care, right? So you're going to do some sort of algorithm, whatever calculation it is that you remember, about how we multiply fractions. Okay, you don't have to do anything special. Just if you'd walked in on day one and I said to multiply these three or solve these three problems, what would you do? Okay, so go ahead and hit pause now for a moment and then go ahead and work those out. Again, you will include those in your homework when you upload it on Sunday. Okay, so hit pause real quick and then I'm going to make an adjustment myself. Okay, so I'm sure you had enough time to do those problems. Now I'll take a look at the solutions here real quick. So there's the problem. I'm going to slide it over to the left just a little bit so that we can kind of see these problems. All right, so there we go. And if I'm going to be showing how to do this problem, what I started with was my red box, which was 3/4. So I broke it into 4 parts, and then I colored in 3 of them. So that red column, that red column, and that red column. And then for multiplication, I don't draw a second box or a third box. I draw on the same box. So for this one, I go ahead and 2/3, and I just made sure that I did it horizontally this time. And then I colored in the top box for 1/3 and the bottom box for the second third. And then the answer to this problem is what boxes overlap. So I see that I have 1, 2, 3, 4, 5, 6 that overlap. And so my answer then is 6 pieces, and the size of these pieces are 12ths. All right, so I have 6/12ths in there. Okay, so I'm sure that's not too bad. That was stuff that we were doing last week. Now, I don't know how you did these problems. I'm going to show what I think most people probably did. And if you didn't do it this way, don't worry about it. It's no big deal. So the first one here, I'm thinking that most of us thought was relatively straightforward because I have 4/5 and 1/3. And when I'm multiplying fractions, I literally can just multiply straight across. So I multiply straight across and I get 4, because 4 times 1 is 4, and 5 times 3 is 15, so 4/15. Already done, simplified, nice and easy. The next one was a little bit, maybe a tad bit harder because it wasn't quite as straightforward. Let's see if I can zoom in here. Okay, so for this one, I did 3 times 8, which was, I did 3 times 2, which was 6, and then 8 times 3, which was 24. And then I noticed that I could simplify that, and maybe you noticed it was simplified by 6s or 2s or 3s, whatever. But eventually you'll get to the simplification where it's 1/4. Okay, so it's not, again, not too bad. There's a little simplifying to do at the end, but not too bad. And then this bottom one here probably was the one that gave you the most struggles, or maybe you just kind of said, I don't really need to finish that problem because that was a long time ago, which is fine with me as well. So here we go. See if I can zoom in on this work. Okay. So the very first thing that I did was I had to turn my 5 and 5/6 into an improper fraction. That's that right there. Okay, so I turned it into an improper fraction. And then I had to turn in my 2 and 2/7 into an improper fraction. So that's right there. And then, based on what we did over here, and here actually, we just multiplied straight across. So I get 35 times 16, and I had to do that work down here. I couldn't do that in my head, so I came up with 560. So that's that number right there. And then I did 6 times 7, which is 42. Now this one can be simplified. I have an improper fraction. That means I have to go back to a mixed number. So again, I could not do 42 into 516 in my head. So I did a little long division here. If you did upwards division, that's fantastic. If you did repeated subtraction, that's also fantastic. But I'm guessing most of us, if we fall back into our old habits, did this. So 40 went into 516 13 times, and I had 14 left over. So that's 14 40-seconds. And then I realized that this can be simplified. And maybe you realized it could be simplified by 14. Maybe you didn't. You might have thought it was simplified by 7 or something like that. But eventually it will simplify down into 13 and 1/3. Okay? All right, so I don't really care that much if you figured this out or you remember how to do it. We're going to learn this today. But I just wanted to see kind of where you're at and kind of give you some feedback on where you were. So, okay, I'm going to go ahead and pause you again and set up my next slides. Okay, so for this next part here, I'm not gonna have you do these, right? You're not actually gonna physically do these. We're gonna talk about them real quick, and I actually have the answers over there, so you'll be able to see if what you're thinking is correct. But these you do not need to turn in to the homework, right? That first set that we did, yes, these we're just gonna be thinking about. Okay, so what I want you to do is just think about how you would solve these. So I'm hoping when you look at these problems, you go, okay, let me look at number 1 real quick, look at number 2, number 3, number 4, and number 5. And I'm hoping that you go 1, 2, and 3 are pretty simple, right? I can do those almost in my head. So now 4, definitely not in my head, and 5, we're just barely talking about that today. So I'm going to go ahead and quickly show 1, 2, and 3 because I think we can probably do those pretty close to in our head, if not in our head. And those solutions are right there. So for this one, because we have common denominators, the great thing about common denominators is I can just add my numerators together. So I get 4 plus 1 is 5/9, done. This one, we learned that really what I'm trying to do here is borrow from this 4 and make it into pieces that are that size. So I borrow from the 4 and make it 3 7/7. So 3 7/7 minus 3/7 gives me 3 4/7, right? So that's pretty simple. And this one actually probably is the easiest of them all, because if we just understand what this is telling me that I have 6 5/8, and that's how I write 6 5/8. So I literally don't have to do anything. Certainly on these two, we do not want to put a 1 underneath it. And then it brings down to this one. So we've probably remembered doing these. We've done quite a few of these, but I'm going to go ahead and show the work over here. I've already done it. I didn't ask you guys to do it because I think we can do it. I just want to talk about it here. Okay, so I rewrote the problem even so that it was up there. Okay, so, okay, let me zoom in just a tad. I'm trying to make that a little bit bigger for y'all. Okay, so the way we learned to do these was that we said, oh, you know what? I know this is 8 holes minus 3 holes. So 8 holes minus 3 holes gives me 5. And then I still need to do 4/9 minus 2/15. So I did that work right here. And I'm not going to go through each step. You can see the 4/9 there. And then I broke it down into its the factors. And I broke it down into the 15 into its factors. And then I was looking to see what each one was missing. Well, I saw that this 3 times 3 was missing that 5. So that's what I multiplied by 5/5. And over here I realized that the 3 times 5 was missing one of these 3's. So I multiplied that by 3/3. And that's what I got here. So I brought the 5 down because that's still in there. But now I have 4 times 5 is 20. And then 5 times 3 times 3 is 45. And over here I have 2 times 3 is 6. And I have 3 times 5 times 3 is also 45. Now I have the same size pieces, so I can go ahead and subtract. So I still have my 5, which is right there. And then I have 20 minus 6 is 14 over 45 for my final answer. Okay, now we're going to take a look at the last problem there, and you'll notice that I actually haven't done it yet. Let me get this lined up pretty good. Okay, so what would be awesome is if we could do the exact same thing that we did for the previous problem. Meaning, it would be really great if I could just say that I want to go 3 times 2 and give me 6. Just like I did 8 minus 3 gave me 5. So we're going to do this a little bit differently first, though. So we're going to take a look at this problem, and let's see. So if I look at this, and we go back to this, the beginning of fractions, we were kind of saying which one is bigger, which one is bigger. So if you look at this, this is 3 and almost a full one, right? It's almost completely full. 3/4 is very close to 3. So if I were to round this, I would say that this one is about equal to 4, right? Over here, this is 2 full ones, and it's almost equal to full. So 4/5 is very close to a full one. So I would say that this one is about, if I were going to round it, it's about 3. So now what I have is pretty close to 4 times pretty close to 3 should give me about 12. So my answer should be pretty close to 12, right? Do you agree with that? So we've got this whole thing here is almost 4. This whole thing is almost 3. And so almost 4 times almost 3 should be almost 12. So it should be pretty close to 12. So if I do what we did before, and notice that I'm going to do this in red here because this is not going to work so well. And I say, okay, I'm going to multiply 3 times 2, right? So 3 times 2 equals 6. And then all I have to do is 3/4 times 4/5. And I can say, okay, that's going to be 6 and 12/20. And I know that 12/20 can be simplified, divide top and bottom by 4. So I'm going to end up with 6 and 3/5. Would you say that 6 and 3/5 is pretty close to 12? It's like half, barely over half of that. So clearly something went wrong. So unfortunately, the strategy that we used for adding and subtracting, of where we can handle the whole numbers first, does not work for multiplication. Nope, it would be awesome if it did, but it doesn't. And that's why I teach adding and subtracting together, because those techniques are the same. And I teach multiplication completely separately from adding and subtracting. So what we're going to do now is we're going to take a look and see how we actually can solve this problem, or these types of problems. Okay. So what we can't do, one of the main things I got to get across today is where before I could handle my whole numbers separately from my fractions. For adding and subtracting, you can do 8 times or minus 3 and then do 4/9 minus 2/15. But you cannot do 3 times 2 and then 3/4 times 4/5. And I'll tell you real quickly why you can't do that. It's because this 3 is being multiplied not just by the 2, it's also being multiplied by the 4/5. And that's what we missed out on. That's why this is so low. It's because the 3 is not multiplying the 4/5. And this 2 is not just multiplying by 3, it's also being multiplied by 3/4. So I'm missing out on the 2 times 3/4, just like I'm missing out on the 3 times 4/15. And that's why this number is way too low if we're going to be super close to 12. Okay? Okay, so what I'm going to do next is I'm going to do some problems, and then we will see how it works out. So I'm going to go ahead and pause it again here. Okay, so by the way, if you were curious, I just did that problem we did a second ago, and the actual answer was going to be 10.5. And so that's actually pretty close to 12. If you remember, our estimated answer was 12. Slide this over so you can see what I just wrote there. Estimated answer was 12, and when I actually did the work, it came out to 10.5. So when we're done with this, if you want to check and see if you can come up with 10.5 as well, you should be able to. Okay, so here we go. So I have a couple problems up here that we're looking at, and I want to show you how I like to do these problems. And one of the things that I'm going to show you, I'm very confident you have already seen before, but I'm also very confident that if you don't do it, it's because you were never required to do it. So one difference is that I think if you want students to do something, you have to require them to do it. Just asking them to do it probably is not going to be enough for them to actually do it. Okay, so I think what a lot of us remember doing is for multiplication, which is not wrong, right? Is that we could multiply our numerators together and then multiply our denominators together. And I agree that 100% works every single time. The problem is you then create solutions over here, answers that the kids now have to simplify. And if they forget to simplify, they get it wrong. Or if they simplify incorrectly, they get it wrong. Or if they didn't even know they were supposed to simplify, they get it wrong. So again, they do all the stuff that we tell them to do, but then they get the wrong answer. We're trying to avoid that. So what I have them do is this, and this is where those divisibility rules can really pay off when students are good at understanding the divisibility rules. They can find a lot more shorter ways of doing this stuff. So the first thing I'm going to have them do is I'm going to have them break these down into their factors. Okay, so I'm just going ahead and write this again real quick here. I don't know why I didn't give myself more room. Okay, so I'm going to break it down into 18, excuse me, not 18 came from, sorry about that, 8/10, okay, times 3/4. All right, so when I break these down into the factors, what I'm trying to find are factors that are in common from the numerator and the denominators. So I look at this one and I know, you know what's in here? I can break this down into 2 times 4. And I can break this one into 2 times 5. All right, and then that still equals 8 and that still equals 10. It's just broken into its factors. And then what I do is I look and see, okay, is there anything I can break down in this one? Well, what I'm looking for are factors that are in common, I'm going to use that 4 and use that 4 because I don't need to break them down. Yes, I could break them down to 2 times 2 and 2 times 2, but it doesn't help me in any way. It doesn't make it easier, so I'm not going to do it. So I'm just going to do it just the way it is. Now, here's what I have my students do. It's called the funky ones. Okay, the funky ones. Funky ones. If you're looking, whoops, that's probably not on the board. Nope, so I'll do right over here. The funky ones. They're looking for the funky ones. And you'll see why, not so much on this, well, a little bit on this problem, but in a lot of problems, you'll see why I call them funky ones. So the funky ones, obviously right here. Well, this one right here is not very funky. That's a pretty normal looking one. And the reason it's a 1 is because I have 2 over 2, right? So 2 over 2 is equal to 1. This one over here is also a funky one. So any numerator with any denominator that is exactly the same can be drawn as a funky one. So I have this, and this is where it looks like a funky one because it's actually laying down. It's kind of slanted, okay? So I have these 2 simplified out, and I have those 2 4s simplified out, and then I have this one left that I cannot simplify, and I have this one left that I cannot simplify. So at this point, I get to multiply straight across. So what I have on top is a funky 1 times a funky 1 times a 3, which equals 3. Am I on the board? Nope. There we go. Okay. So I have a funky 1 times a funky 1 times a 3, which equals 3. And then I have a funky 1 times 5 times a funky 1, which is 5. So my answer is 3/5. All right. Okay, so that's the basic process that we're going to do. It doesn't really matter what the fractions look like. We're going to do this before we finish our problem off. We're going to always find our funky ones. All right, so now I look at the next one here, and I've got 12/27 and 180 over 14. So what I'm doing here is I'm looking, what factors do I know? Well, I know that I could break this into 2 and 6, but 6 doesn't go into 27, so that doesn't do me a whole lot of good. I know I could break it into 3 and 4, and I kind of like that. So if I understand my divisibility rules, 7 plus 2 is 9, and that means 3 goes in there. 3 times 9, just like that. And I look over here, and that's going to be 3 times 4. Now I come over here, and I go, oh my gosh, 180, what the heck? What do I know about 180? Well, if I add those together, 1 plus 8 is 9 plus 0. Hey, this divides by 9. So this is going to be 9 times something. Now, I might not know what that is, but at least I know that 9 is going to go into 180, and that gives me a shot to find a factor for it. And maybe they go, you know what, 9 times 2 is 18, so 9 times 20 is 180. Especially if they're used to doing expanded form multiplication, that's not too hard for them. And then here I go, okay, 14, well, I don't know much about 14 except for 2 and 7. I don't have any 2s or 7s up there, but I notice I have a 20 here that has a 2 in it. So I wonder if I could do that. Sure enough, I can do this into 2 times 7. And then this 20 here, I'm going to go ahead and make it a little easier, is going to be 2 times 10. So now I actually broke this 20 down into 2 times 10 so that I'll have a funky 1 with the 2's. All right. So now I don't see anything else that I can break down. I have 10 and 7 and 4 and 9. Those don't, or 3, those don't seem to do much. So now I can do my funky 1's. So there's a funky 1 right there. I've got that 9, and that 9 is definitely a funky looking 1. And then I have this 2, and that 2 is also a funky 1. Now, when you're doing this, it gets kind of convoluted and kind of wild here. So I think a good strategy at the end, once they think they've simplified all of their funky 1's out, is have them go back and circle their numbers that they did not multiply, that didn't multiply out. Okay, so now I can multiply straight across because all the numbers inside of circles cannot be simplified. No numerator with no denominator. By the way, you can't do 4 and 10, even though they both have a 2 in it. And the reason we can't do that is because those are both numerators. It's got to be a numerator with a denominator. Any numerator with any denominator when you're multiplying fractions can be simplified. So now I have 1 times 4 times 1 times 1 times 10, which equals 40. And then I have 1 times 1 times 1 times 7, which equals 7. So now I have 40 70ths, and I need to simplify that, or I want to simplify it, I should say. And so now what I would have, this is why I have them do the upwards division, because a lot of times they get to fractions that are very similar to this and say, okay, upwards division is pretty simple. 7 goes into 40 5 times, that's 35, with a 5 remainder over 7. So my final answer is 5 and 5/7. Okay, so that was not too bad. I mean, there's a lot going on there. There's funky 1's are all over the place, and it does get convoluted. So circling the ones that you're going to be multiplying at the end is a little bit of a help. All right, now let's take a look at this one. This one definitely has the most going on. So what I noticed first about this one as compared to the previous one is this has mixed numbers in it, right? All the others we've done so far don't have any mixed numbers. They're just fraction times a fraction. This has a mixed number in it, and so does this. So I don't like that. We already talked about how I can't go 2 times 3, right? That doesn't work. It works for adding and subtracting. You can add whole numbers or subtract whole numbers, but for multiplication, I cannot multiply 2 times 3. I need to get rid of those whole numbers. And basically what I'm trying to figure out is how many pieces would live inside of 2 wholes if I'm talking about 9s. Well, clearly there would be 9 plus another 9. So that means there'd be 18 just in these 2. And then I have those 7. So I'd add 18 plus 7. So I'd have a total of 25 pieces that are this size. Over here, if I have 3 tenths, if I have 3 wholes and they're broken up into tenths size pieces, then that would be equal to 30 pieces. Just for each one of those, be 10, 10, and 10. So that's 30 pieces, but then I still have those 3, so then I'd have a total of 33 pieces that are this size. So I'm gonna go ahead and show you how I show my students to do that. I call it the backwards C. And it's kind of a misleading name because the C actually doesn't end up backwards. What's backwards about it is how we write the C. If you notice when I wrote this C right here, I just did it real quick. I think most of us, except for my own children, they don't do it this way, but most of us start a C at the top and then we go down to the bottom like that. Very few of us start at the bottom and go up to the top. And that's what I mean about a backwards C, is that it's not that the C is written backwards, it's that how we write the C is opposite of what we normally do. We normally don't start at the bottom and go to the top. But that's what I do here. For this, to turn this into an improper fraction, I start at the bottom here and I go that direction like that. And then what I do is I say, okay, how many pieces am I going to have of ninths? And then I have to add the pieces that I started with. I still have these 7 left over, so whatever that equals plus 7 gives me my total number of pieces. So I have 9 times 2 is 18, plus 7 is 25. And what size pieces are those? Well, those are ninths. And then I'm going to do the same thing right here, the backwards C. See, again, the C does not actually end up being backwards, but how I write it is backwards. And then I'm going to multiply, because I got to figure out how many pieces this would have in it. That's going to have 30 pieces plus 3 more, which would give me 33 over 10. Okay, now I have no more mixed numbers. I have only improper fractions. So now I can break it down. So again, just like before, I'm going to break it down. I see, you know what? That looks like it could be a 5 times a 5, because that over there would be a 2 times a 5. And then I see this could be 3 times 11. And this one could be 3 times 3. All right? So that's not too bad. That factoring, breaking up into factors was pretty simple, actually. So here I go. I'm going to say, okay, what do I have? Some funky ones. Well, I see there's a funky one right there. And I see this 5 right here, and this 5 right here could be a funky one. It doesn't matter which 5 I use. I could have used either 5. Same thing with the 3s. I could use either 3. Now I see that what I have are 5, 3, 11, and 2. So nothing else is going to simplify. So I'll go ahead and circle the ones that did not get simplified out. And 5 times 11 is 55. And 3 times 2 is 6. All right? So 5 times 11 is 55, and 3 times 2 is 6. Now I got to figure out how many times does 6 go into 55. So I think that is 9 times 6 is 54. And then there's 1 left over. So 9 and 1/6. All right? So there you go. That's how I do all of my fractions. If I have an improper fraction, if I have a mixed number, I change to an improper fraction, and then I always simplify. This part right here, the simplifying first, is critical. What we don't want to do is to have them multiply straight across. If they do that, that's when they create things like this. From that very first problem, they have 560 over 42 because they had to multiply 35 times 16 when they could have simplified the 7 and the 5 right off the bat and the 6 and the 16 right off the bat. It would have been a much simpler problem. Anytime we can keep the numbers small for our students, the better. So even though you can get to the same answer, that's not how I want my students to do it. I want them to try and simplify first, because there's way less errors occurring if they do that. If you think about this problem, they would have had to multiply 25 times 33 and then divide that answer by 90 and come up with 9 and 1/6. That is not a very realistic thing. Okay, I'm going to show you one more quick thing that kind of refers back to what we did at the beginning. What number is this pretty close to? 2 and 7/9 is about what number? Well, that's 7/9 is pretty close to 1. So if I round that up, it's about 3. 3 and 3/10. If I were to round that to the closest whole number, it would be about 3. And so 3 times 3 is equal to about 9. And you see that our actual answer was super close to 9. So I want my students to think about that and to estimate. So if their answers aren't close to their estimation, what went wrong? Because that's pretty simple to do. That's pretty close to 3. That's pretty close to 3. 3 times 3 equals 9. So my answer had better be super close to 9. Having our students estimate is super helpful for them. Okay, last one for the lecture, and then we got a couple for practice. All right, so here we go. Okay, so I'm gonna do this a little bit quicker, less talking and more just working it here. So, okay, I'm going to do the backwards C because I don't like those improper fractions. If you wanted to simplify the 4/6 right off the bat because you noticed it simplifies out, there's nothing wrong with that. I'm not going to do that just because it's a little bit more messy and it's already hard to read in my board. So that's the only reason I'm not doing it. So 4 times 6 is 24, plus 4 is 28 over 6. And then here it's like this, the backwards C. 2 times 35 is 70, plus 8 is 78 over 35. All right. Now I need to break these down into their parts, or what they simplify to, and I see 28 and 35. The only thing I know about those two numbers is it's 7 times something. So that's 4 times 7, and this one is 7 times 5. Now these two are a little bit trickier, so 6 is pretty simple, but I see that 78. So if I use my my divisibility rules and I go, I wonder if 3 or 9 work. 7 plus 8 is 15. 15 is divisible by 3, and it's an even number. So that means it's also divisible by 2. So if this number is divisible by both 2 and 3, that means it's divisible by 6. And that's what I like because 6 is already down here. So now I need to know how many times does 6 go into 78? Well, it's going to go in there 13 times. And the kids might not be able to do that in their head. They will, if you ask them to, they can start doing their head, but maybe they do a little side problem over here to find it out, a little division, or maybe even they do 78 divided by 6 and they do their upwards division, which would be awesome. It's basically what I did. I just didn't rewrite it. Okay, so next I'm looking for finding my ones. So the whole work I did here of the 6 and the 6 are my ones, right? So those simplify out. And then over here I see a 7 and a 7. So those simplify out, and then that's all I have. So I've got that 4 left over, that 13 left over, and that 5 left over. And there's nothing I can do top and bottom, numerator to denominator. So now I multiply across. So I get 4 times 13, which equals 42 over 5. 1 times 1 times 5, I guess I should say. So, I'm sorry, that is not 42, it's 52. All right, so 52. And then 5 goes in 52 10 times with 2 left over. Okay, so 10 and 2/5. Okay, so I'm gonna take a quick look here and see how close this was. So here, that is pretty close to 5, right? If you round that up, it's gonna be about 5. And this one, 2 and 8/35, that's about 2. So I get about 10, which is obviously super close to 10 and 2/5. Okay, so that's the lesson, right? That's how you do these problems. This is required. Like, I don't want you to go 28 times 78 and then divide that by 6 times 35. I don't want you to multiply first. I don't want your students to multiply first. This will help them when they get into algebra. There's some skills they need in algebra that are required. This skill is required for them to be able to do that. So you'll be setting your students up for success later down the road. Yes, it's a little bit more work when they're in 4th grade and they're trying to figure this out, but I'd rather do a little bit more work in 4th grade and a lot less work when they're in algebra, and it's something that can grow with them. All right, so I'm going to put you on pause one last time and then talk about the end here. Okay, so I'm gonna have you guys try these, and what you're gonna do is the same thing we basically just did, and look to simplify first, factor it out, find your funky ones, make an improper fraction if you need to, and then factor it out and find your funky ones. And then, of course, always at the end, simplify if you end up with a improper fraction. I will tell you, I forgot to mention this, if you do your funky ones well, if you factor and do your funky ones well, at the end, you'll never need to simplify other than making it an improper or a mixed number. So you should already be simplified, except for the fact that you might end up with an improper, and then you just do upwards division to be done. So I'm going to go ahead and pause it one more time, then I'm going to put the answers up. And again, you can include these, or you can change that. You need to include these in your homework so that I know that you were following along with the video. So you can include these in the homework. And when you see the answers, you can make any adjustments that you might need. Okay, so there's the first answer, and I'm gonna pause in between each one and make them big as I can make it so you can see. But here you go. You see that I broke these into its factors here in green. The blue is my funky ones, and there's my simplified answer. Okay, 1 second. Okay, so here's the second one, and you see the very first thing I had to do over here in red was make it improper fractions by doing the backwards C. Then I broke each one of those down so that I could then do my funky ones. I ended up with an improper fraction here, so then I did upwards division and got to my 18 2/3. All right, and one last problem to take a look at. All right, so here you go. So again, I had to do the backwards C to make them improper fractions. And this one is a mess in here. In fact, I'm going to zoom in so you can see it a little bit bigger and then I'll zoom back out. All right, so if you look at this one was one of those ones that you got to go slow. So the 63 here, I broke into 9 times 4, or 4 times 9. And then I broke the 4 into 2 times 2 and the 9 into 3 times 3. Because I saw down at the bottom, I had a 3 that I could simplify there, and a 2 I could simplify there, and a 2 I could simplify there. So I saw that I had all this stuff on the bottom that would simplify out if I broke those down a little bit further. This is definitely a little bit trickier question for our students to do, but they'll get there and they'll be able to simplify them correctly. And so then what I'm left with then is that 3 on the top, everything else simplified out, and that 5 on the top, and everything on the bottom simplified out. So I'm left just with 15 for my final answer. So that's the probably the most difficult one you could have them do because they have to simplify some numbers twice, but certainly well within their skill sets. Okay, keep the text messages coming. If you have questions, you need to Zoom, please do not hesitate to text me and we'll find some time to Zoom. But that's the lesson for today, and I will upload a few fraction problems for us to do. They'll be heavy on multiplication, but I'll probably throw in some addition and subtraction ones as well. But mainly it's multiplication. Okay, have a great day, and I will talk with you guys soon.